pretty much what I've got is that if we're doing this, all we're really talking about is basic machine design. So what I'm talking about is in the software. So we'll just look at the software here. And so we have a project that, it's just the regular old demo set here, but all right, so we're going to look at just this motor. Now, this motor, I've got all kinds of numbers going to it already. So you see this symbol. This symbol has, if I go ahead and open up the symbol, I have circuits associated to every connection point that a wire would come to. Yeah. Okay, those circuits can be designated for the type that it is. So that way you could use this symbol for a number of devices.
Yeah,
whether
regardless of what the actual input on it is, or like what sort of wire you're using,
or the fact of which manufacturer, whether it's Allen Bradley, whether it's this Leroy Somer, whatever the case is.
All that the program cares about is that it's a motor and it has the same connections.
Correct, and it designates how many connection points I have. So that I am now selecting if I want to add another, maybe a neutral or a tack to this motor, I would simply add another circuit to this symbol. So if I go to new circuit, I could create one that is a tachometer. And I might just call that miscellaneous. And it's still disconnectable. You know the difference between disconnectable and passing? Passing means that I'm sending the power through it, but a disconnectable would be that I am ending the power at that for use.
Okay.
Okay. So I'm looking at it being disconnectable, and I might have something like, of course, under my more circuits here, I probably don't have a TAC or a PG, so I would probably just call that a miscellaneous. And once I create a miscellaneous, I will have down here a circuit number 4. So right now I've got 4 circuits. This would be circuit number 5 as far as physical count. And I could add a new connection point to it. And it's just a matter of having the connection point and then dropping it wherever. So if I drop it down here, let's go back to that. Oops. Where is that? I got to turn on my snap. My snap is on. What do I have for my grid?
This snap is a little bit different than because like I've used SolidWorks before for 3D modeling type applications.
Okay.
I've never used it for actual electrical stuff.
How is it different? Are you talking about just? I mean, because the snap is going to snap to a grid point.
Yes.
Okay, and so you designate the start of your grid point, the lower corner, and the upper right. So you're doing.
The main thing that was different for me was that with like your general SolidWorks, it doesn't snap to like a grid; it snaps to certain
quadrants,
certain objects.
Okay, all right.
Rather than actual grid, which I think is actually nice for this because then you don't have problems with like, oh, my line is just like a hair off because it didn't snap right.
Right, yep. And you can do the similar type of stuff where you can still do measurements to make sure that from this point to, see, the next point should be here, which should be 0.25, so I'm actually off. Yeah. So I need to actually grab this and actually bring this. No, grab that. And I want to snap it to, looks like there. And this is just the attribute that it is coming in with, is this P tag 4. All right, let's measure that again to make sure I've got that at 1/4 inch. Because, of course, the spacing, 0.23. Really? All right. Then I'm just going to grab it, and we're just going to, is it that one? Measure again. See, normally what I do is I don't do it in this direction. 0.75 close, but not quite. What I end up doing is creating from a like a black box symbol, which a black box symbol will create these connection points for you. And so what you end up then having is you have that capability of designating the spacing before you even start, where here I am, I'm picking and checking, and so of course, like, this is still off, it's 0.3, doesn't matter, we're not going to worry about that. But notice, okay, so we've got these circuits. So right now I have those circuits and I have these attributes. Now, these attributes, what are they? In 2017, I did create a What's New video that you can watch. And actually what you can see then is some of the new stuff that's going on. But right now, under this insert attribute, you have a list and it shows you what some of these are and gives you a description. So you are looking for different pieces that you are adding to this motor. So like if I were to look over here as this information, where that's coming from, notice the difference. Here I've got manufacturer's part information, and then I also have other information. This tag is the most important part of the entire software. Okay, the reason it's the most important is this. So I'm going to come over here to this board, because of course this board looks like it is not being necessary here.
That makes it way easier.
How long before like the video is available online?
For this?
Yeah.
Probably tomorrow, or however long it takes the guys to actually publish it, because I give it to them at the end of the night.
Okay, cool. Yes.
So, all right, so we've got this tag. Now, what is the tag? The tag is the entire set of devices, like the motor, has an ID number. So we're going to call it M1 for lack of a better understanding at this point. Okay, so that is this symbol, but it's not just the symbol. All right, so if I look at that, we're talking about, I'm just going to say, sure, I can say that. All right, so I've got this motor, it says 604. I'm going to change it real quick here. So that way it says M1. I'm just going to make it M1. Now,
it automatically, between automatic and manual for that, it'll mark it according to like a
formula.
Okay, so like a grid line that you set up on there.
So if you notice right now, I am on sheet number 6.
Yes.
And not only am I on sheet number 6.
Line 3.
I am actually on line 4.
Yeah.
Yeah, so that's why this one here says 607.
Oh,
because
yeah.
it is on row 7.
Yeah,
Okay, so
I didn't
that's
know
the
it
formula.
automatically did that. That's
It will do that, yes, for you, depending on what you have set up in the project template. I know
it's working so much better.
Good.
And he had shown me that like if you have a component linked to, like, say you have a motor protection circuit breaker, and then you've got like a contact on there, then it'll link that and it'll call it the same designation, which is kind of cool.
Yes. Okay, so because you've got this tag, now the first thing that we're looking at, you have a schematic symbol that represents that tag. Right?
Yes.
Okay? This tag is the component. So the second thing that you can have is manufacturer parts, but it is parts as in plural. You could have, in our case here, that motor, maybe a tack, maybe a brake. Those are all part of that same motor.
Yeah.
Okay? When you start designing and laying things out, as in a just a line layout would be of a conveyor, the first thing that you would have then is you would have a footprint of that motor, possibly that you might be laying it out on your layout, right? Still a part of the tag, but it is now a physical block that takes up so much real estate.
Yeah.
Okay. Another one that you
on
might
the
have
actual schematic.
Not on the schematic, on the line layout of your equipment. You might say that a limit switch is placed here. If you're going to say the cabinet is placed here, you're going to say the conveyor
Oh,
is here.
on like your actual panel layout.
This is, yes, this would be like a line layout of your equipment.
So like the physical area that it would take up, not like the physical area, or like the virtual area that like a symbol would take up.
Correct.
Oh, okay.
Okay. Then on top of that, if you had a 3D assembly, you might also have a 3D model of that motor. Okay?
Mm-hmm.
So now, if you change the information to this, you are changing it for all of them. This is where the libraries come into play.
Yeah.
But this tag is what is the most critical. Okay? So when I start playing around with this, of course, back here where we are discussing this motor here, this motor, the symbol showed that we had 4 circuits. Those 4 circuits we knew as motors, motor phases.
Yeah.
And then we knew that there was a ground. This manufacturer, then let me go ahead and delete the manufacturer's part first. So I'm going to go into the component properties and I'm going to delete this manufacturer. Because what you have then, yes, I know that. Delete this. Delete. There we go. The red significance here is saying this is what you drew. This is what the symbol knows it needs.
Yeah.
Okay. So now if you know that this is what it needs, now you can find any manufacturer that will satisfy those requirements.
Okay. Yeah, he was showing me part of that this morning.
Okay. So every manufacturer's part, if I go into my search, this is going into the library of your manufacturer's parts now. When you go into this, you now have that capability of searching all the motors. And you can say specifically that I only want to have motors that have 4 circuits. So I can now come here, and it's going to look through my entire library, and it's going to only select the ones when I say 4 circuits. Now, the reason it has all these different ones here is because these are the capabilities on my library right now. Mm-hmm. I can do 2 of all of these motors because notice up here, my class is saying motors. So I am looking only in the motors. I can then say that, yes, I want 4 connections. And now it's going to only give me a list in the top of the 4 circuits. So when I select one, it will highlight whether it matches or not.
Yeah, with like the designation that you actually have in the schematic. Yes. The attribute type? No, that is the circuits. We are only looking at the circuits right now. Okay. At the circuit level, it realizes that it matches, it has 3 motor and 1 ground. If I highlight that and double click it, it puts it down in here. Now I can still add the tech, the brake, by just going in here and searching for more parts. Mm-hmm. And when I double click on them, it will add them in this section. When I do, it puts it automatically on the bill of materials. It automatically populates throughout. Yes. Okay. Yes. Cool. Okay. Now, what does that do for me? Okay. This is the specific manufacturer that I have added. Mm-hmm. Notice when I edit, I have all of this information that is available to me here. So I have the part number, the manufacturer, the class. I have whether you've got a stock supplier that you use, or maybe a specific vendor. Maybe they have a specific vendor number. We use article number for if there's a fog filler number. Yeah. Okay, but there's other information that you can add in here. The size. This will designate on the footprint how much size it takes in real estate when you were placing it on a physical floor. All right. When you go to draw it, what it's going to do is then scale that for you. So whatever
based
scale
off of
you're drawing.
what this is here, whatever your drawing scale is, it will then readjust these sizes to be realistic to scale,
Okay,
depending on what the scale is of the drawing.
that's really
So if you say 1 to 10, then the motor is going to be so big.
One question.
Sure.
So how critical is the two-dimensional footprint, so to say? Like, let's say I pulled one offline, or I copied it from another drawing that we had,
Sure.
and how can I say this? Let's say it was supposed to be, this, a certain size,
Sure.
but it wasn't correct on the drawing.
Yep.
Then I use that for my
If you
2D.
put the dimensions in here,
Mhm.
then what it's going to do is look at the outer boundaries. It's going to be a DWG that you've created. All right, so if that DWG of your motor kind of looks like this with the bumps for the frame, and then comes to here, and then you might have the fan here, and then you might have a shaft. What it's going to do is measure the outer dimension from here to here, and that's going to be your width or your height.
that
Okay?
is really handy.
And then from here to here is going to be the height. Now, when it goes to utilize this, it will then take the dimensions there and drop those in, no matter what size it was physically drawn at.
Okay.
So if you had text out here, now all of a sudden this becomes out here.
Oh, it doesn't
You
distinguish.
do have to be
That I
very
didn't know.
careful of that.
Yeah.
It doesn't distinguish between like
No,
between
no.
line types.
No,
And
it's
that's, I
looking
think,
at outer boundaries.
Just outer.
Outer boundaries.
Okay.
So if you want to add text,
keep it within.
add it in here.
Okay.
Any type of attributes or anything.
It's typically in the
inside.
on the footprint. I mean, I learned right away that I didn't want anything outside, just because it's, you're drawing things.
Yes.
So it really didn't matter. So I always tried to keep that text in.
Inside the footprint,
Yes,
yes.
of course, learning that like 2 years.
Yep.
I was having a lot of problems with that, but that was.
Yep, that's where that comes from. Now, what's really cool is if you have a specific footprint for a specific manufacturer, because it has a specific frame size, you can actually assign that right here where it says 2D footprint. So because you can assign it here, it will always, if you grab this manufacturer, it will use that footprint you have created specific for this motor.
That is.
So when you go to do that layout of your equipment, you can now grab that specifically because it already has it. It knows that you've used this motor. This is the footprint you want to use for this device.
That is so useful.
Yeah, it can be.
It
can be.
Well,
It can
we
be.
just did a CIP one, and someone was like, "Can we fit it in a smaller box?" And so I kind of took all the stuff that we had in the panel layout and tried to migrate into a smaller box, and it looked like we had size for everything and like the room to spare everywhere. And I go and actually put it in the box, and I had to move everything around because
it would fit, but not quite.
Yeah, it wasn't like some of the sizes were slightly off, and it ended up adding up.
Right. Yep. So I'm going to take a picture of this here just so that I can add this to the.
Perfect.
In fact, I'm going to take and turn off this light real quick here so I can take a better picture of what we've got here and add it to our video later. Okay, so now is it starting, does it make a little bit of sense where we're going with this?
Yeah.
Okay, now, this information that we've got up here is part of the information that it will then pick up when we are looking at the attributes section. Because the attributes, what it is doing is grabbing this part number. It is grabbing this manufacturer. I can actually start adding some information to this. Notice there's this user data field down here. This user data field, you can actually have up to 40 different between user data and translatable data. You can have extra information. So maybe on this one, I'm going to call this that it is, what do I want to call this one? We'll just call this a we'll call this a pump filter or something. Oh, we'll just call it a washer. All right. So now when I say okay, go ahead.
When you, like, if you say you grab that ABB motor, like, you grab an operated motor,
Yep.
you throw it in there.
Yep.
Will those other fields, if you have it set to that manufacturer and motor type, will those automatically populate, or are those just there for you to put in?
They will automatically populate. It's
Okay,
pulling
so
that
like the
from.
size.
So
and
right
everything,
here,
it'll pull
this
from
it's
that
pulling.
tag.
It pulled the ABB. It pulled the part number. This 22. If we go back into it, that what we have? We have 22 and we have 1430. So that information in the component is the information from this unit. 1430 is right here. That is the speed.
Oh, okay.
Power is the 2,2. So you can add.
You just don't have like a 2D thing set or a width or height for this one specifically.
Correct, because I haven't done anything as far as a 2D layout for
Well, like,
this.
had you set this for it, it would automatically.
Oh yeah, then what I would do, I would take this, now that I've got this M1, and I would go into my project here and create a layout.
Yeah.
And so we're going to do, if we do process, we're going to do a cabinet layout. Now we're going to do it of just the main line. So actually, you know what? The main line, that is L4. So we're going to do just that one. Uncheck all of these so that way I don't have it.
Those different designators on there that you're unchecking, those are things set.
Those are assembly. Those are assemblies. You're familiar with SolidWorks and assemblies and sub-assemblies?
Yes.
Consider an electrical project an entire top assembly. Okay. And each area that you are dropping components into is a sub-assembly or a location. So you could have a sub-assembly being just the control panel. You could have another sub-assembly being a junction box. You could now have another sub-assembly being all of the field devices.
Okay.
L4 is all the other conveyors, which is just that. It's the field devices.
So then you could set that between like that motor that you got there and say you had a VFD in front of it. Sure. You could set that individually to a different sub-assembly for each of those.
Exactly.
The properties.
So now when I go to this other layout, anything that you see here is in that location. So now I would start laying out maybe from my mechanical guys. Maybe they gave me a DWG of just a top view of the entire line layout. So I have my entire conveyor sitting here, and I would now start placing things like M1. Notice I have a footprint here. It's going to tell me it doesn't have one because it doesn't have so it already does. I am going at a 1 to 10 scale. Okay. Because everything is 0, 0 right now, it is incorrect in my manufacturer, but it's picking up a generic symbol. If I don't have one, it's going to pick up a generic one as long as I've got a dimension.
Okay, so you have there's a preset thing of symbols in there. Like
a preset set of symbols, and it is right here under the library, under the component classification. So I said that this was a motor, so it is automatically picking up a default that I have for this. So that's where it's coming up with, and that's why you classify.
So there's like a standard for everything, but you can
generic, but you can exactly.
Okay.
So you don't have to set up everything for yourself, but if you want to,
if you really want to delve into that,
oh, you bet. So if we look at this motor, let's look at the properties of that motor again before we get going on this. So that motor, we'll say the motor itself, and now it says it's the width is in millimeters. So, all right, we'll say something weird like what motor is about 2,500. 2,500. That's what? That's 100 inches. That's huge.
Right.
Okay. How about 2,500, 1,200. How about 900 millimeters? Would that be about right? Yes, we'll go with 900. We'll make it a rectangle type. So here we'll go, maybe this is 450. Well, that's small, but yeah. All right, and if it had a depth, maybe it looks like that. All right, so there's the new numbers that we have now. So we're going to update the catalog, which means the library now has it. So now anytime that I use that part, it's going to now have it available. Okay, so that even if you grab this motor again, it's going to have that information.
Automatically populate.
Right, so now when I go to insert this part, notice that what I've got. I have a motor that is the correct size, and I would place this on my conveyor somewhere. And right now I haven't adjusted it so it has a small, because the tag is small compared to that, because it's a very large motor. But we're doing a 1 to 10 scale. So if I were looking at a prox now, maybe this prox here, there's the size of a standard prox. And it's actually giving you that prox. So you're building from that library. All you're having to do is create some dimensions, and it's going to start giving you realistic architecture for where the real estate is being used.
Yeah.
So that, if you're now trying to look at where do I run cables, now I need to run a cable from here back to the control panel. And then from the control panel, I need to take it back to the motor. And I have to make sure that if it's a collapsing or telescoping conveyor, that it stays out of the way of the wheels and all that type of stuff. So you can see that as you're laying this out.
You can actually get an accurate picture of the layout.
Yes.
Like the difference between just having drawings of parts in like a regular CAD program in SolidWorks where you can actually like see how they interact.
True, you could take it to that extent. In schematic, though, we're staying in a 2D flat environment. If you purchase the 3D product, which as a student, you can get the 3D product through your school.
Oh.
You can get 3D electrical. You'd have to talk with your school about all of that.
Do they have like a PCB?
Yes, we do PCB as well. That's a whole nother conversation.
Ball of worms, yeah.
No, it's not a ball of worms. It's just another conversation. So here we are now that we have, something here that we can start with. So you can actually do an entire layout just by the fact that you have created a schematic and you're telling this motor. If you look at this, when I look back at that component again, you'll notice that here is my location. It says that I am under other conveyors. I designate where it goes, and then I can start doing my layouts.
Yeah.
And when I pull up that layout, it's going to only bring up the devices that I've put in that location, which means any terminals that I want in a junction box. If I put the location in the junction box, it's not going to show up on the list to put in the main panel.
Yeah.
So I can actually tell it where it's going to be. But yet in my bill of materials, I can either have a list of everything, or I could break it down into locations and have specific reports for each location.
Okay.
Okay, does that kind of...
Yeah, it definitely, it makes the whole method of doing it more concrete. It seems like it makes the process of actually making a print way smarter, as long as you put in the initial...
Sure. Now, you can just as easily design the schematic first and drop in the parts later.
Yeah.
It's 6 of one, half dozen of the other. But what's really nice is that when I go ahead, and let me go ahead and delete that device again, just for the heck of it. Notice what happens. Normally, you would have to go through and you would have to scan all your prints, find which ones you're missing. You'd have to open them up, figure it out if you weren't using the attributes. But what's really nice is this software also has reports and these things called design rule checks. The design rule checks are your own personal audits. So that you can create a design rule check that will actually look for you through the entire project. For right here are manufacturer's parts assigned to components but not used, because you don't want to put parts maybe in 3D. Somebody created something but you never designed for it. Mm-hmm. So they could be ordering it on a bill of materials and you didn't design for it, so it shouldn't be there. Or the other one that is my favorite here is this one for components for circuits right here. Components with circuits not assigned to a manufactured part. So if you're overuse or not using the entire circuit, what are entire component? How about components missing manufacturer's parts? So that would be that motor.
Yeah.
If I look at that motor now, so here's the one with manufacturer's parts, oops, components with circuits not assigned. Notice there's the M1 right there. These are all the ones that you still have to add a manufacturer's part to.
Okay.
Now notice right now it is the second one, so let me come back in here. We'll now add another part to that. I don't care what it is. We just can grab something here and add it. All right, so it now has a new ABB part. And now this now is available, but now look at what happens with my design rule check. So now notice that right now, manufacturer's parts assigned to components but not used. Nope, that's not the one I want. Here's the one I want. Components with circuits not assigned to a manufacturer. Nope, that's not the one I want. There it is. Components with missing manufacturers. Notice M1 is not in this list anymore. So it's automatically doing those audits for you, so you can actually work right off this list. You go to this one, you go to page 5 here where this one's located at, you then can find it, you assign it, you come back in here, you do the next one, but you're not having to go and figure it out for yourself. The software is saying, hey, you need this, hey, you need that. So that way you're not going to have those issues where you release a set of prints and you forget to designate something.
Yeah, it takes some of the human error out of it.
Takes a lot of it out of it. Because as long as the library is correct and everything is spelled correctly, nobody's going to mistype it. And that means when it gets sent off to purchasing, you're going to have the right part number that you requested because nobody fat-fingered it.
Yeah. That first part, the manufactured parts assigned a component but not used, would that fix some of the 200 number stuff that we deal with, Phil? Like getting parts that are in like a 200 number that shouldn't be.
Yes and no, because what'll have to happen is, because it's a totally separate system, we'll have to compare them and say, well, why is ours coming up with one set of list of parts and this one including that?
It could be used as an error check, but
it'll be for our drawing, yes, but for when people actually order that,
okay,
we could say, okay, so this 200 blah 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 is good. We've error checked it, we've drawn it, we've proved that it's good here. We'll take that number, plug it into ours, and that could still be wrong.
Okay,
So then we'll have to compare.
Okay, now the one that you have, is it database driven?
I'm pretty sure because it's the one that we make in house.
Okay, so you do have, which we have never talked about this. You do have this ERP. Okay, so the ERP is under. Let's see here. I got to remember where this is at. ERP connection.
I think it's application settings.
Nope. Application settings is where you set up for the databases for the information for where it's stored and how we're communicating. But there's the rights management, so it's not there. Libraries right here. ERP database connections. So this will allow you to actually come in here and create another connection to another database. So your purchasing database. And what you can end up doing is you can either read or read-write to it. I would suggest read until you actually are you've worked it out with your IT people. But you would find the server. It would then actually allow you, as long as the manufacturer's part number and name are here, you can then set up what gets associated back and forth from our library to that library, so that if you have specific part numbers, they would then populate back through and you would have these available. This information you could then use in a report, or you could use as an attribute on the symbol or anywhere else. So any of your reports that you're generating for.
But this is just reports, not necessarily assemblies, correct?
2017, you can do assemblies too.
Okay.
It's what we call a super part. And that super part will allow you to create a conglomerate or a kit of parts. where you could actually have those called out.
'Cause, yeah, we need to kind of merge those two together.
Yeah.
It's the hardest part is, you know, once with 2016, I basically started over. I said, okay, I made a lot of mistakes because of how new I was to all of that stuff.
Sure,
But I
sure.
kind of purged, but I did bring some things back because it was just too long of a process to not.
Oh, sure.
You know.
Especially the macros that you were trying to do with the, a 5 horsepower, 10 horsepower, 20 horsepower motor, where you were bringing in all of that circuitry here and then just redoing it based off of which one you were looking at for the size. Yeah, so I mean, that part of it, I can definitely see where the advantages of keeping what you had before, rather than redoing anything, where that would help out.
But it's made it a lot. I mean, I've used a lot more of the tools this time around, especially with the user data fields.
Good, good.
And even down to like labeling them for like fall user data, or sometimes if you go into the go back to the motor.
Yep.
And double click.
Yep.
And then so the manufactured parts and circuits. If we look at what's in there, see how there's only one part, so that will have like its own article number that we use.
Right.
But if you have multiples in there.
Yep.
Is there a way to display
the auxiliary parts on the symbol yet? No.
And that's what I've been doing is that a lot of times I'll say additional parts.
Yes.
And I'll put a 6-1, then.
Oh, perfect. Yes. Yes.
Use that. It's come in really handy. So that way I can just say, all right, user data field text.
Right.
Here, and then I just put in regular text, additional parts, and then label, drop in those.
Yep.
Worked out so well.
Yeah, there is a server or a software enhancement request for that, but that has not taken place yet. So yeah, if I were to add a secondary piece here, so now that I've got these two, unfortunately that ABE is not going to show up on anything more than the bill of materials. So unfortunately, that's where, you do have to use those user data fields to at least signify what else you're actually adding.
And it's nice though because, once you get comfortable with them, it stays within that.
Right, especially if you create that as a macro, you've already got all of that there. So that just makes it that much easier. Which you're familiar with what a macro is?
I was just going to ask that. That's kind of like what you were talking about where you could put in that whole line of motor, basically have like the PCB, the VFD, and the motor already.
Yep.
So you know how when we order based on like a power, so if we need a 5 horsepower setup.
Yeah, it's a specific MPCB, and it's all the same for that horsepower.
The drive, the terminals, the breaker, or if we have a disconnect.
Yeah.
So that number, then I would just say, okay, well that's 200 dash whatever.
Right.
Then I would just grab the whole thing, and then she'll do it, and you just drag it over to the side, drop it in, and
call it the 5 horsepower motor.
That's how you create like a macro type thing. Okay.
Yeah, motor circuit. But the thing that's really nice about this is that not only can you designate this, but you can actually, when you bring it back in for use. So let's just grab it and we'll just drop it. Let's just drop it right here.
Yeah.
I can create new information or old. And when I say finish now, this is still another motor. It's the same, but yet I can actually make changes to this if I need to once I bring it back in. So it is now a new, maybe if I'm looking at this component here, this disconnect has this piece to it. I could actually edit that just by making changes either to this part itself. No, I don't want to modify that.
So it's its own individual symbol now.
It's now its own separate entities all the way across the board. It's lost its identity from what it had here. It is now just separate individual pieces that's now fully editable, but yet it still retains the old information.
What you have to be really careful with too is, like, say the first, and this is where Mrs. Clark's really kind of messed me up, was that Mrs. Clark only had one main panel, right? So we didn't have a JB2, and we terminated the motors directly into that main, we didn't have a JB1. So with that, I had to be careful with not using that as a full macro, so to say, because let's say I put it into a standard filler. then I would drop that in, and all those would be just the main cabinet.
Right.
There
Yeah.
would be no separation.
Well, what you can do is actually what I would do here is suggest that you can actually using these under the, let's see here, where is that? That is under the schematic. You can use these location outlines where you can actually say that this is a specific location. So that this is on the subplate of the main panel that you can, yes.
Oh, that's huge.
So, and then you can say, and then you save that as the macro,
Yeah.
where you are now saying a location now for this motor is over here and it's going to be under this other conveyors. And so when you do that and then save this as the macro now,
Yeah.
it now has those locations as callouts. So when you bring them back in, you can either reassign them to where they should be or make new ones.
Yeah.
So now maybe this is the 10 horsepower. And now when you bring that back in, now it's going to have the fact of whether you want to keep existing locations or do you want to create new. When you create new and then go to next, you can actually designate what it should be.
Right there when you create it.
Yep.
That's really handy.
Or you can associate it to the existing. So I can say associate that to this one here.
You recall our conversation earlier when I asked you how long are you going to be here?
Right.
Because my idea is that I work on the new master for this. My thought was that you can just be creating the macros. It'll give you a lot of experience with the drawing and getting all that set up. And I can just be chipping away at the rest of the setup and adapting it. Because as long as you understand, okay, what the locations are, how the parts all get,
Yep.
populated together.
Yeah.
Yep.
And what, the eventual outcome is, putting it on a report. That's a huge help for me.
Yep.
Yeah, I'd be very interested.
Yep, and see this, what you have here under the locations. Notice over here on the left-hand side, this is how it's laid out. So this looks more like a file explorer type scenario.
Yeah.
This is giving you the overall, saying this is the master, this is the actual mark. If you follow the left-hand side there, it tells you exactly where it's being set up at. That this has this piece, this has this piece. You can create more just by saying new location and calling this maybe the fact that this description is, a junction box. And when you call it a junction box, you now have a new location called the junction box so that you could actually place terminals there and do whatever you wanted to. But yes, the big thing is when you are selecting a component, where is the component going to be in the sub-assemblies? Is it going to be in one specific spot? Is it going to be on a conveyor and inside a cabinet somewhere? Is it going to be on a specific conveyor? Is it going to be in a specific field area?
Yeah.
You designate where that's at, and that will help with either the report if you're separating it out, or it will help when you're doing the plant layout or equipment layouts for where the footprint should show up at.
This is so cool. This is like going from a Flintstones car to a Hyperloop.
It can. It can.
This is really cool.
All right.
It's a hard one to solve there, but
Yeah.
your advantage is that you haven't done what they're doing for that long because they're used to that.
Yeah.
Well,
So-
yes.
and that's
Any
the hardest
other
part.
CAD packages, you learn bad habits. If you notice, I have a grid. And I use grids. I use ortho when I am drawing lines because when you are drawing lines, you can either I can draw one single line and I can draw it multiple times. I can draw it a ½ inch apart, but I draw straight.
Right.
In CAD symbols, you do not need to draw straight. Now, why would I draw a straight line? Because when I am trying to take a symbol like this, and snap it to the wires, or even a symbol like this, where it has to be straight, or both sides do not connect. If both sides do not connect, you know what happens?
And here it actually
Here it matters because if you don't grab it that way and snap it, it will not break the wires. Because right now, originally, this is a wire. This knows it's a wire, but it's self-healing if it's straight because it knows that it goes from one spot to the other.
I like that so much.
When you come in here and drop in a symbol into the, okay, now I got to turn the ortho off, or the ortho off so that I can actually bring it back. Come on, turn it off. There we go. I can now snap it here. It self-heals, but it also will break if the lines are straight. If the lines are straight, even if they're 1/10 of a millimeter off, it will not connect to both sides of the circuit. So it doesn't know that it needs to be there.
And she's not kidding when it's 1/10 off because
we've done it. Yes, we've done it. But notice what happened. I also have other things here. I pulled that circuit from here. Notice the blue dots.
You got mad,
Well, notice why. This is L310. This is L19. Different wire designation all the way across the board because this was a reversing motor starter. So it knows that there is a problem here now with those 3 wires. And it tells you. You can do a couple of things. One, I can take this wire and push it through by saying wire style propagate, and I can push that wire style through, and it'll change this wire, but it still has not, let's see. Yep, do that. All right, cancel this. Now, this is...
Would you have to select that next wire in it?
Yeah, we don't. What you need to do is this. The second half to this is solving the equipotential conflict. Notice this one says L110. This one says L39. I would simply have to now tell it to solve the equipotential conflicts, and it wants to know which wire number I want it to be because it knows that it's two wire numbers I'm trying to connect up. It can't. It needs you to tell it which way to actually do that. I can show you that.
Which one is the one you want?
Yep, which one is the driving one that you are actually doing. So here, once I do that, it now knows. So here, let me show you one. All right, so if I create another green wire or blue wire there, let's just do one wire. Oh, in fact, there's even an easier way to do that, but here, I will select this one wire there and only select the neutral. All right, so I'm just selecting that neutral wire so that I can select this blue wire here, and I'm just going to draw another blue wire right here. And now what's really cool is, of course, I can use things like processing and number the new wires. So it's only going to number this new wire here. It's N6. Now notice it's the same type of thing. It's the same wire, same style wire. It knows it's neutral. But when I go ahead and connect these 2 wires up, so now if I go to my schematic here and I connect those 2 wires up from one spot to the other, so I'm just going to come over here and say single insertion from that spot. Oh, wrong one. We'll go over to there for that one. All right, and then do another single insertion, so from here to here. All right, and now I'm done.
It'll like automatically put your cross references in there.
It already has. So it now knows that I am at sheet 6 at page 22 is where this one is going to. This one's at 6. This one goes to page 7, row 2. So that's where it's coming up with those.
Say you had that terminating into like some sort of contact that was going into an IO piece.
Yep.
Say you wanted to move that contact down to like the 3rd input instead of the 1st one. Would that automatically change your cross references?
No, not unless because that's in the circuit itself. Your circuit designation would change, not the wire going to that connection. You would have to change the wire location.
But if you change that wire down too, it would automatically.
Sure. So if I were to take this right now and bring it to here, notice it automatically changes. Okay, so yes, if you do that, yes, it does. But notice the wire numbers. The wire numbers N3 and N6. So now I would have to select one to actually solve this. And when I say solve it, it would then resolve itself, but tell it that it matches. So same thing even goes here. So this one here, I went and have the same problem where on that one, I have two different wire numbers. So if I
Yeah.
tell it this is the right one, it solves it. But then you've got hyperlinks here that then allow you to go to that other location. It opens up the sheet and takes you directly to it.
That's so cool.
So yeah, even changing wire numbers, which used to be an absolute pain.
Yeah, this software's gonna, you guys, they're not gonna even need interns here anymore.
No, you need interns. Interns, yes, you will need interns, but I can actually create an entire set of wire numbers, and when I type it in
Beautiful
once,
wire.
it then populates all the wires with that wire number.
That is so nice.
Yeah. All right, so you've had me for 45 minutes. If